In 2018, China opened a road across the sea. 55 kilometers of open ocean, 3 cities connected, a 3-hour journey cut down to 30 minutes. But before any of that happened, China's engineers hit 3 walls, 3 problems that had no existing solution. 3 moments where the entire project could have stopped, permanently. This is the story of how they broke through each one. Problem number 1. The ships. The Pearl River Delta is one of the busiest shipping lanes on the planet. Every single day, massive cargo ships move through this stretch of water, carrying goods to and from the ports of Hong Kong and Guangzhou. These are not small vessels. These are some of the largest ships ever built, standing taller than 10-story buildings above the waterline. The shipping lane handles enormous volumes of maritime traffic every week. Stopping that traffic, even temporarily, was not an option. Now imagine you need to build a bridge across this same water. A bridge low enough for normal construction would block those ships completely, shut down one of the world's busiest shipping corridors, and cause billions in economic damage every single year. That was never going to happen. So, go higher, right? Build the bridge tall enough for the ships to pass underneath. Here is the problem. To build a bridge tall enough for a massive cargo ship to pass under, you need approach ramps on both sides. Those ramps have to rise gradually. Otherwise, no truck, no car, no bus could drive them. At the height required, those ramps would stretch for kilometers on each side. They would consume land that doesn't exist. They would cost more than the bridge itself. The geometry simply doesn't work. Engineers were stuck. A low bridge kills the shipping lane. A high bridge kills the budget and the geography. Don't go over the ships. Go under them. Build the bridge across most of the crossing. But in the section where the largest vessels travel, drop the road underground. Sink it beneath the seabed. Build an undersea tunnel. Pass under the shipping lane entirely and rise back up on the other side. For the first time, the project had a path forward. But that solution immediately created a problem nobody had solved before. Problem number 2. The tunnel had nowhere to begin and nowhere to end. Most bridges connect land. This one had to create it first. An undersea tunnel cannot simply start in the middle of the ocean. The road has to transition from bridge level, above the water, down to tunnel level, below the seabed. That transition requires solid ground. A point where vehicles slow down, the road dips underground, and the tunnel begins. But at the exact locations where the tunnel needed to start and finish, there was nothing. No land, no shallow reef, no natural foundation of any kind. Just open ocean, 46 meters deep. Without transition points, the tunnel could not exist. And without the tunnel, the entire crossing collapsed. Engineers were not missing a component. They were missing the ground itself, so they built it. 2 artificial islands, one at each end of the tunnel, constructed from absolute zero in the middle of an active shipping lane. Engineers drove over 120 giant steel cylinders deep into the seabed. Each cylinder was the size of a large building. These cylinders formed a ring. Workers then pumped sand and concrete inside, filling them completely solid until the tops rose above the waterline. Then they built the tunnel entrance structures, emergency facilities, and maintenance buildings directly on top. The 2 islands together cover over 200,000 square meters. Both were completed in just over 2 years. Engineers from other countries watching the construction timeline called it nearly impossible. The islands went up anyway. The tunnel finally had somewhere to begin and somewhere to end. But now came the problem that nearly broke the entire project. Problem number 3. How do you place an 80,000-ton object onto the seabed with an error margin measured in centimeters? The tunnel was not dug from above. Drilling through a live seabed under an active shipping lane, that was not feasible. Instead, engineers chose a different method. Build the tunnel in sections on land. Transport them by sea, sink them to the bottom. Connect them underwater like a giant puzzle. 33 sections, each one longer than 3 football fields, each one weighing approximately 80,000 tons. Here is the impossible part. Each section had to land on the seabed and connect to the previous one within centimeters of perfect alignment. Not meters, centimeters. For an 80,000-ton object being maneuvered through open ocean, descending through 46 meters of water in near zero visibility, with underwater currents constantly pushing against it. No existing vessel had been designed for this combination of scale and precision. So China built one. Custom ships designed and manufactured specifically for this project, equipped with GPS-guided positioning systems accurate to within 2 centimeters. They could hold an 80,000-ton tunnel section suspended mid-water and make micro-adjustments, millimeter by millimeter, until the alignment was exact. Each section took days to place. Divers worked in near-zero visibility to monitor every connection. Any misalignment in the seal under that pressure at that depth would have been catastrophic and nearly impossible to repair, with 80,000 tons already sitting on the seabed. All 33 sections landed successfully. The tunnel sealed and open to traffic. Problem 3 solved. The bridge opened on October 24, 2018. 55 kilometers total, 420,000 tons of steel, enough to build 60 Eiffel Towers, over 1 million cubic meters of concrete, a cost of $18.8 billion US, 9 years of construction. The result? The longest sea-crossing bridge tunnel system ever built on Earth. A world record that still stands today. The 3-hour road journey from Hong Kong to Zhuhai became 30 minutes. The Pearl River Delta, home to over 70 million people and responsible for roughly a quarter of China's total exports, tightened into a single connected system. Factories, ports, airports, and financial centers that once operated in isolation could now function as one. In 2023 alone, the bridge carried over 15 million passengers, and it was engineered to keep doing that for a long time. The entire structure is designed to last 120 years, built to survive magnitude 8 earthquakes and super typhoons simultaneously. 3 problems, each one without a ready solution. Each one solved by building something that had never existed before. Most bridges connect land. This one had to create it first. Next week, China needed to control one of the world's most dangerous rivers. The answer became the largest power station ever built in human history, the Three Gorges Dam. Subscribe, and I'll see you next week.